Excellent. Thank you so much. Yeah, welcome everybody. Glad you're here. We got a great webinar for you today. You can see the title on the screen, and hopefully you know what you're getting into, but we're going to go very technical and heads down. But first, I'd like to welcome Anu Sharma and Jeff Fry. Thanks for joining us. They're going to be walking you through a detailed run through of Docker, AWS, and JFrog. Anush, how are you? Great to see
Hey,
you.
thank you. Hey, thank you,
Hey.
Peter. Thanks for the introduction and good morning, good evening. Welcome all to this webinar and excited to take you through this journey as we go forward. I'm Anuj. I'm a container specialist solution architect at AWS. Been with AWS for over 5 years, and looking forward to talk with you all. About any questions that you may have in this about this webinar and the content of it. Over to you, Jeff.
Great, thanks, Anuj. Yeah, I'm Jeff Fry, a Senior Technical Alliance Manager on the Business Development team at JFrog, but don't let the title fool you. I've been an engineer and developer for most of my career. So some have said that I've crossed over to the dark side when I came over to business development, but that is not the case. In all seriousness, being on the business development team, it's great to see how the engineering impacts the business, particularly with our partnerships. Also want to say it's great to work with you, Peter and Nuj, on this webinar. After our Docker Hub partnership announcement earlier in this year, it's great to continue working with you and Docker.
Yeah, awesome.
Awesome.
I think
so
Jeff,
with
you
that,
take it away, man.
Yeah, here we go. So just we'll give you some quick slides on overview of JFrog if you're not familiar with us. So at JFrog, our goal is to bring order to your software delivery process. We understand that you have multiple development teams. They're using multiple different languages. They're using different technologies, different platforms, different tool chains, and it can be a mess. And so our goal is to have JFrog as the hub of this ecosystem of technologies. So we provide a unified platform that has some of the major components. So I'll go over those in the next slide. But with that, we understand we need to support the ecosystem. So we have integrations as well as integration endpoints that support your software delivery lifecycle at all the different stages. On to the JFrog platform. So this is just a high-level overview. So the platform itself consists of several components, all responsible for different operations in your software delivery lifecycle. So the first one I'll talk about is JFrog Pipelines. And so this is our CI/CD solution. This is what's responsible for automating and orchestrating your software build, test, delivery, release, and deploy process. The next one from that is we have our JFrog Artifactory. Put the arrow on there. And so this is what JFrog's most known for. This is the leader in artifact management. So it supports many different languages. So whether you're doing development in Java, JavaScript, we support all those different software package types. Today we'll be talking about Docker images, but we support creating those repos and actually storing and delivering those artifacts from those repos. Connected to Artifactory is our next product. This is our security product called Xray. And so what Xray does, it scans those software packages, identifies any security vulnerabilities, also identifies license compliance issues. So if your development teams are using open source libraries and there's certain libraries that you don't want in your software, certain license types that you don't want in your software, you can support that that's supported in Xray. So Xray will automatically scan these software packages in Artifactory. We also have a connection between Xray and pipelines. And so this supports shift left DevSecOps best practices. So as you're building your software with JFrog pipelines, Xray can identify security vulnerability or a license compliance issue in that build process and stop the build, preventing vulnerabilities from going into your production environments. And then moving on to distribution and JFrog Edge. So these products are part of our release process. So once you have a software package or an image This is usually part of a larger application that has multiple images, multiple software packages. And so with distribution and edge, what you're able to do is create a release bundle that brings all of these applications together and makes them immutable. You can sign these, and then the distribution product delivers these to our JFrog edge points. And these are usually like in data centers or point of sale systems. We have them in large warehouses where they're supporting software and servers there. And then finally, we have our mission control and insight. So this is the management layer for the whole platform. So this is able to give you control over all the different components, gives you status on what's going on with your software delivery process, and provides logging and insights so you can understand, potentially if there's any issues with your software delivery process, areas where you may need improvements. All right, so today in this webinar, we're talking AWS and Docker. So let's talk specifically right now about how JFrog Platform supports AWS. So you can run the JFrog Platform on AWS Cloud, where we manage the platform for you. So this is what you would consider a SaaS offering. As part of that, we do have a free forever tier so that you can use JFrog Artifactory, Xray, and Pipelines free forever with certain usage limits. You can also get the JFrog Cloud on AWS through the AWS Marketplace. Now, if you're looking to run JFrog in a self-managed way, we do have JFrog Platform deployable from AWS Marketplace. You can do this also with AWS Quick Starts. So this is a great way to use the JFrog Platform if you want to manage it yourself in your own accounts. And then for our on-prem customers, if you're using AWS Outposts on-prem, JFrog Platform has been validated and verified to work on AWS Outposts as well. And then finally here, the JFrog Platform supports a bunch of integrations with AWS. With JFrog Pipelines, we have the AWS CLI built into it. So you can control all your AWS services. So, whether you need to configure or deploy to EKS, EC2, ECS, or Lambda, you can do that with the JFrog Platform. Today, we're going to talk about how you're able to do this with Docker Compose onto ECS. And then moving on to JFrog and Docker. So JFrog Artifactory natively supports Docker image registries. So JFrog supports not only local repositories, but we can proxy to remote repositories, including Docker Hub. And then earlier this year, we announced that with a partnership with Docker, we can allow unlimited access to Docker Hub via Artifactory. Also for your remote repositories, we support image caching, which allows high performance artifact delivery to your development teams. And then finally with JFrog Xray, we mentioned earlier that we can scan Docker images. And so we can notify you again of those security vulnerabilities and license compliance issues. And the integration with pipelines allows us to, again, stop your software build process, prevent any issues from popping up in production where much more difficult to solve, and then you don't want that getting into the newspapers. All right, so let's talk about the demo that we'll be doing today. So in this demo, we have some example code. We'll be building this sort of augmented reality 3D application. And using JFrog Pipelines, we'll pull that code and then do a Docker build. So this will build a Docker image. We'll push it to a dev registry or repository. Once we do that, typically you would have a test, but we're skipping that for today. Then we do a promotion. So we're going to promote that from a dev repository to a production repository. And then finally, we're going to use Docker Compose, which is going to create an ECS cluster for us and deploy that application into the cluster. All along the way, we're collecting build information. So this provides traceability to your software builds. And then Xray, again, will scan these Docker images. I'll show you what that looks like. Now, just taking a look at the AWS architecture that we'll be creating as part of with help of Docker Compose. Again, we're using JFrog Pipelines, also Docker Compose, creating that image. That gets deployed to Artifactory and Xray again. But what the slick part happens is when we use Docker Compose. So again, that will create the ECS cluster into your default VPC. They'll create the internet gateway for you, application load balancer, subnets, the ECS cluster, create the task definition and the service, do all that for you all in one shot, and then deploy your application. So it's pretty slick. And now with that, I'll hand it over to Anuj. We'll talk about Docker Compose. Oops.
Awesome. Thank you, Jeff.
I'll stop sharing there.
Yep, awesome. Now let me take you through a journey that that Jeff briefly described in the demo that we'll be going through today. And this is a topic that our leaders also discussed previously in the session. That hey, we are considering typical enterprises talk about doing the migration and modernization onto AWS, but how does that journey actually looks like, and what are the challenges that they usually encounter? We will go through that journey as we take this experience further. But before we do that, let's have a quick primer on what exactly is Docker Compose, so that we can level set on the journey that we'll be beginning today and that we'll be going through today. So Docker Compose is a command line tool that uses a specifically formatted descriptor file to make multiple containers and assemble them into applications which can then be used to run on a single host. The application services are configured using YAML files. It actually allows developers to run commands on several containers at the same time. This means that developers can write a YAML configuration file for their application services and subsequently just use one command, which is like Docker Compose up or Docker Compose down, to simply start the entire environment end to end, which can consist of multiple Docker containers. This tool was originally developed for Linux, but it is now available for most of the operating systems, including Linux and Mac OS. Now, you may wonder why would developer typically use Docker Compose to begin with. So first, for a background, it is one of the most popular tool used by developers. There are around 43,000 repositories in GitHub public, which is growing almost every day, and over 1 million Docker Compose files. It is the Docker Compose tool is also an open source project with strong community support, and we'd love to hear feedback from you to make the product iterations better. Secondly, the huge benefit is the portability. The Docker, the command line, which is Docker Compose up, is all by itself is enough to bring the entire application or the entire development environment end to end, and it can be turned down again with another command, Docker Compose down. This means that developers can centralize their development environments and deploy applications pretty seamlessly. Thirdly, testing in the form of unit and end-to-end testing. It's one of the Docker Compose main feature which can be leveraged. It allows for a convenient and repeatable testing without mandating any change in the environment, which makes it possible to run an environment very similar to what you would run in an actual production circumstances, instead of having to test that application on a local or a host operating system. Docker Compose can accommodate several isolated environments just in one host, allowing developers to rely on the same machine to run multiple copies of the same given environment. And finally, using Docker Compose, it also means that you are not taking the risk of one service actually interfering, or one project interfering with another project, and it ensures the service level isolation from project to project basis. Now let's see what it takes to run a sample 3-tier application locally. For a typical application to run anywhere, you will need basically around 4 different components. volumes, secrets, networks, and images. A container is a runtime instance of an image. Docker volumes are the preferred mechanism for persisting data generated by and used by containers. Docker volume is how one service actually communicates with each other. In local machine, it's typically DNS. And Docker secrets is the mechanism to store the secrets locally. Secrets are mounted onto a specific location runtime inside the container. Now, each tier may need to have its own Docker object communicating with each other using networking of some form or another form. This complexity typically grows with your application as the number of objects keeps growing with your application. There comes, in my opinion, the Docker Compose to the rescue, where you actually declare the entire application object declaratively in a YAML file. And then you use the Docker Compose up commands, which directs the Docker daemon to look for the Compose YAML file and creates all the necessary objects end to end for each application tier, including the networking. And that's how you'll typically run an application locally, and we'll see that in the hands-on session also today. Now, imagine that running a sample 3-tier application on AWS, and now we're talking about the migration journey to be very specific. Each objects that we create, I mean, basically, if you have to migrate the application onto AWS, imagine that the equivalent infrastructure that you will end up creating for running the entire 3-tier application end to end will require you to write somewhere around 700 to 800 lines of AWS CloudFormation template, and not to mention this YAML code basically that you will write using AWS CloudFormation template. It is not the same, and it's basically totally different than what developers have actually used for their local development purposes. Now, however, with the Docker Compose ECS integration, you can use the same Docker Compose files that was used during the development flow and deploy the application pretty seamlessly into AWS ECS without any additional work. And we'll go through that just in a bit. Now, when you're running the same Docker Compose up command against the AWS ECS context, the same Compose files will generate Amazon EFS, which is Elastic File System for volumes, run containers in ECS Fargate, use AWS Secrets Manager for Docker secrets, and generate security groups with bare minimum rules, and use AWS Cloud Map for service-to-service communication. And also, it will create application and or network load balancer for ingressing into ECS services. All right, so let me take you through the code and this migration and modernization journey from an application developer perspective. So first up, a quick overview from the application to be very specific. We have, and I just want to make sure that everyone is able to see the screen that I'm sharing, which has the code in it. Jeff or Peter, is that?
Yes, we can see it.
Yep.
Awesome. Awesome. All right. So a typical application, as we talked about, can have a backend database and a front end. Front end, in our case, in the sample, is nothing but an Nginx layer, but this could be a AngularJS or a Node.js application. The Docker file in this case is Nginx layer, and it simply copies the configuration from local to the container. The database tier has nothing in it because we will download the database image from Docker Hub directly. And finally, the backend tier, which has the Python 3.8 Alpine image, and it has the sample code that we intend to run today. We'll do pip install and whatnot. Now, if I have to join these three layers, these three different tiers of the application, the sample Docker Compose file will look something like this. So as we mentioned that there are like typically around 4 different components which are required. First step is Docker volumes. We will create the volume named as DB data. We will also create a secret named as DB password, which is typically required for the application to communicate with the database. And we will mount it to, or basically the Docker Compose natively will mount it to run secrets when the container actually instantiates. And we will use networks as backnet and frontend. These are the named networks, which will which essentially allows the service level isolation. Now, talking about the services, as we saw, there are like around 3 different tiers. The front end tier, let's say we have to build that application locally, and we can use the build command with the context specifically pointed to the Docker file where it runs locally. And we declare a dependency on the backend just to make sure that the front end will start only after the backend. And the ports which are exposed is 3000 to make sure that the application is available on the port 3000. The backend tier, very similarly on local machine, it is we have to build that application locally using the Docker file, which is present at this location. It mounts the secret that we created, which is a DB password, and it depends on the database layer just to make sure that the backend tier starts only when the database tier instantiates. And as you mentioned, that it depends on the backnet tier and backnet network and the front net network. And finally, the database tier. We are going to use the base image from Docker Hub, and that's pretty much the verified image Docker, which Docker Hub provides. And we will mount few environment variables here, along with the volumes for data persistence. So very on a very quick level, let's say if I have to run this application locally, I can use Docker compose up command, and that's going to bring the entire application end to end, creating all the things that we discussed: volume, secrets, network, passwords, and whatnot. And my application is pretty much up to it's running end to end. If I have to run this application locally, I can simply do curl http ://localhost/ and so http :// add and something like 2 and anuj. Oops, and that is not right. It is running on port 3000. So port 3000, and there you go. So it initially loads the application, and let's see if I have to add. I'm going to do add to anuj. That's going to simply insert few records into the database. So now coming back, now let's say if I'm happy with the application, I can right now I ran the application in the front tier, but I can run as a daemon so that when I do Docker compose down command, it's going to tear down the entire application which it created. So this will take around like few seconds to complete. Now, let's say with this, I'm happy with my testing end to end, and I did all the possible things, all the development work which I had to do, and happy with my development testing. Now the time comes and wherein I have to actually go about deploying the same infrastructure and lifting and shifting onto Amazon and make it run into AWS cloud. Now, in order to do that, the very first step is to make this integration, which is Docker Compose integration, to run against the ECS context. And in order to do that, you can create Docker context create ECS and give it a name like ECS-demo1. And when you do that, it's going to prompt you a few things, which is where exactly are your credentials stored. In my case, I'm going to use the AWS environment variable, but you can use the existing profile or token credentials as well. All right. So far, we have not deployed anything yet. We are just prepping the CLI to be to communicate against the ECS context. And now what we will do is switch to the context that we just created, which is Docker context use ECS demo. I have another context which is created, so I can actually list all my context here using Docker context ls command. This is the one that we just created, and this is the one which I had pre-provisioned. Again, so far we have not deployed anything. Now, you may wonder that locally I did create volume, secrets, and networks, but what happens when it actually deploys onto ECS, and how does that works? And that is where the beauty of Docker Compose integration comes into place. As in when we run the Docker Compose up commands against the ECS context, it will create an opinionated infrastructure based on all the values that we have specified, and create the equivalent infrastructure onto AWS. When I say by volumes, it will create EFS. It will mount the secrets onto AWS Secrets Manager. It will use load balancers and AWS Cloud Map for the networking perspective. And let's see how to do that. But this specific Docker Compose file is meant to be run locally. As you'll see that here, we are building the application locally. But when it runs to running the application onto AWS, we don't need to build it, because we will be pushing the images into an image repository like Docker Hub or Artifactory. And so in this case, we will use the feature called Docker Compose overlay, and that is very handy to demonstrate the value proposition of overlays and Docker Compose overlays files. I have another file which is Docker Compose prod migrate, and what it does is essentially identifies the delta that we are using from Docker Compose.yaml and Docker Compose prod.migrate.yaml, and it will generate a consolidated compose file in the end, so that it's easier for you to distinguish from local environment, and you're not writing the entire template end to end. There are only few things like images in case of when it is actually getting deployed onto AWS. You just need to use the image which is already pre-built, and use the credentials which are use the credentials from the secrets manager directly to basically pull the images. Now, in order to create the secrets using AWS Secrets Manager, what you will do is you can use Docker secrets command here. And I'm going to do something else here. In this case, Docker Compose 3 pull credential. And you'll see that we are, even though the application or even though we are creating the secrets into Secrets Manager, but we are not doing any context switching. We are using the same CLI, which is Docker CLI, and we are not doing a context switching between AWS CLI and whatnot, right? Because Docker CLI handles everything on its own there. So let's see if I have to create the secret, I can just run this command, and that's going to create the secret for me. Right, and for the purposes of this demo, I'm going to create another one here, call it as Docker credentials 4, and that's going to create the secrets for me. And if I just echo what exactly it created, oops, so I'm going to do just an echo here. Oops, so echo and Docker credentials, secrets manager. Let's copy it here. Right, so that will just output the ARN that we created. Now, next step is overlay Docker Compose file with the prod migrate file. And in order to do that, I can simply run the command like Docker Compose up. And what we are going to do is pass few variables and supplying few variables which are required in the overlay file, which is Docker Hub ID and my pull secrets manager Docker pull secrets manager credential, which we created in the previous step. And we are saying Docker compose up with the file, which is file 1. And secondly, it is the file 2. And we're going to use Docker up command. Before we do that, let's use another command, which is called Docker compose convert. What this command is going to do is actually generate the entire opinionated CloudFormation template for you end to end. And we can I can just pipe the output as foo.yaml, so that we can see the entire template that was generated. Now you'll see that we did not write this code. It is the Docker compose file which generated for us. And it is around 700 lines of code, which is required to be created otherwise, right? And the very next step, what happens is, let's say if I run Docker instead of Docker convert, Docker compose convert, I can run Docker compose up, and that is going to deploy the generated and opinionated infrastructure in terms of CloudFormation template onto AWS. So if I do, and meanwhile this is getting deployed, I have a stack which is already created so that we don't see the entire stack getting created. You'll see once the deployment is complete, you can come to the CloudFormation console and you can see all the resources which were created. You can see that we created the ECS cluster, which and also running the tasks, which are the front end, back end, and the database tier in terms of a Fargate task. We also created the necessary namespaces in terms of front end, back end, and database, so that the service discovery can happen. The Docker Compose also created the load balancer, which is required to front the services and ingress the traffic into the services. And we also created the pull credentials as an example here for pulling down the secrets, as well as this is something which Docker Compose created on its own, just because it identified that there is a need for the secret to be created for the application to communicate with the database tier. And that's why it created in AWS Secrets Manager. And when the container instance is getting initialized onto ECS, this secret is going to get mounted onto a specific location pretty much securely, so that from as far as the data which is getting transferred over the wire, there is absolutely nothing which is visible to anyone. Now, as this application is getting deployed, let's probably not wait. And the very next step is, once you are in the migration journey, once you are sure that, hey, this application is looking good onto AWS, now the time comes for us to actually start optimizing and start making use of the AWS cloud as an example, right? And we don't need to do anything additional in terms of the efforts which are required, right? What we can do is simply create another overlay file and add something like AWS autoscaling as a plugin. And what this will do is enable autoscaling on AWS Fargate task, which will scale the task up whenever the CPU crosses above 75% as an example in this case. There is another capability, and there is another plugin called AWS CloudFormation, and this is pretty much handy. Let's say if you have to create the instance, instead of using the container, the MySQL container instance, if you have to start using AWS RDS instance, you can write the entire the steps which are required to create the RDS instance in AWS CloudFormation stack, and that will create the entire RDS instance for you. And when the time comes to actually change the application from using the container instance running on Fargate to RDS, you can simply use or point it to the RDS instance created with the previous template, and pass it on as an environment variable to the application, so that it's pretty seamless effort as far as the migration and the modernization journey goes. So with this, I think I'm done with the walkthrough as such. But the very next step, as far as the journey comes into place, is how to do the CI/CD aspect, how to do the continuous integration aspect, and how to do the continuous deployment, and how to make sure that the application images are scanned, they are secure enough, they're scanned for any vulnerabilities, which is where the entire JFrog platform comes into place, and it's very handy. And I would hand it over to Jeff to take us through this journey as a next step. All right, over to you, Jeff.
Great, thanks, Anuj. Let me go ahead and go back to sharing here. Great, so Anuj gave you a detailed overview of how you run Docker Compose, locally for your own development, and also then how to turn it over and create your ECS cluster and deploy your applications there. Now we're going to take the next step and show how you can run it with JFrog and do a CI/CD. And so first thing I'm going to do is I'm going to show you the JFrog platform, just kind of give you a quick platform overview. This particular JFrog instance is running in the cloud, so this is a SaaS instance. Again, you can get your own free version of this. So looking over to the left here, we have a unified UI. And first thing I'll show you, here's our Artifactory menu item here that exposes our Artifactory software. So when you're looking at this, the first thing we're going to look at is packages. So again, mentioned earlier, we support many different software languages. And so we have packages here you can see for Docker, for Helm, go further on down there, NPM, any sort of software language that you're working on, we can support archiving those here and delivering them from Artifactory. As part of the CI/CD process, you're going to do your software builds. And so we keep track of your software builds here. As part of that software build, you're going to have build info that's stored. So we keep track of things like environment variables, dependencies, who initiated the build, what was the build agent. Again, this is really important for traceability. And the other view we have here is artifacts, and this really just is our repository view. And so we have virtual repositories, and these have repositories behind them. Let me give an example here. So this particular virtual repository has some local and remote repositories. Local repositories are repositories that reside on this server. Remote repositories are those maybe on another server or maybe something like Docker Hub. Distribution is again for our release process. We don't have distribution set for this particular instance, but we don't have that in the demo. JFrog Pipelines is our CI/CD engine. And so we'll get deeper into this as we execute the demo. But what we're able to do is set up a pipeline that does the build, we'll do the testing, the security scanning, the deployment. And then lastly, here's our Xray product, which is under security and compliance. Here you can set up security policies, license policies, and then under watches, apply those to certain repositories and scan those automatically. All right, so what I'm going to do now is I'm going to switch over and show you the example repo where we're pulling code from, and I'll go ahead and paste this in the chat as well. 1 second here. There we go. All right, so that's the repo I'm going to go through. So we'll be building an example application. It's in this folder here, a workshop app. And this is just a JavaScript NPM application, but this is where we're going to build our Docker image. For JFrog Pipelines, we have something called a pipelines YAML file. I'll take a quick look at that. So CI/CD pipelines and JFrog are defined in this YAML format. And so we have something called resources. And so resources are used as part of the pipeline. And so the first resource we have here is the Git repo. So this is the repo that I just shared with you and where we're going to pull down the code. We define another repo here representing our image. So this would be the Docker image that we produce from this build. And then we have build, 2 build infos. And so this is where we're collecting information as part of this build. Once we get down into the pipeline itself, JFrog Pipeline supports built-in steps. One of the built-in steps we have is Docker build. And so this takes a Docker file location, executes that build, builds the Docker image. We have some lifecycle events here, like an on start and on success. There's an on execute, on failure, where you can execute additional, in this case, bash steps. We're making a quick modification here to include a build number in the application. Once we do the Docker build, we move on to a Docker push. So we built the image. Now we're going to push it to a dev repository. We're going to publish the build info that we collected earlier. And that gets published to Artifactory and associated with that build. Then we're going to do a build promotion. So what this does is you've accepted the dev build, the dev image, and then you're going to promote it to, in this case, we have a production repository. So we're going to promote it there, which ends up copying it there. And the last step we have is the ECS deploy step, which is just a bash step. And so what we're going to do, this is going to integrate with AWS. We're going to go ahead and authenticate with AWS. We're going to execute a deployment script that follows basically the same techniques that Anuj was showing you with Docker Compose. And so let me jump over to this deploy step right here, which has the Docker Compose execution. So this is the deploy. So it's a pretty simple script. All we do here is we install the Docker CLI. And then using the techniques that Anuj showed you earlier, we're going to create an ECS context and give it a name. We're going to say we're going to use that context. And then we're going to execute a Docker Compose on this Docker Compose file, which will kick off creating the ECS cluster, setting up the subnets and everything that Anuj showed you earlier, and then turn around and pull the image down from Artifactory and deploy into that ECS cluster. And lastly here, we're just going to wait here until that application comes up and it's running. And then we'll click on it and we'll show you what the application looks like. If we jump back, I'll show you the Docker Compose. So this is, again, just a single application. Anuj showed you a very complex multi-tier application, but for the purpose of this demo, we just have a very simple web application. You can see how easy this Docker Compose is. This is where we're pulling the image from Artifactory. We'll be serving it on port 80, and the network's being set up. So with that, I will jump back to the JFrog platform. I'll get into the pipelines. And so I've already pulled this pipeline into JFrog Pipelines. It's this pipeline here. So what this has done is it's associated this pipeline with that repository. It's automatically read that pipeline YAML file. And so what we've done is we've set up this pipeline here. And this is a visual representation of the YAML file that I just went through. So here's the Docker build, Docker push. This shows being pushed to a registry. We're going to publish build info. Here's that promotion, and then the ECS deploy. So what I'm going to do is I'm going to go ahead and manually execute this pipeline. But what we can also do is this is hooked up to GitHub via webhook. So if you made a code change, you did a commit, you pushed it, this pipeline will be automatically created or automatically executed. So while this is executing, what I'm going to show you is, again, like when you do a magic trick, you want to show things before they magically appear. So in this environment here, we have our CloudFormation console. And we don't have the CloudFormation stack here yet that creates that ECS cluster. These are some other ones. You can disregard these. But once we get to that deployment step, it'll automatically create it here. And then if I jump over to ECS, and we'll take a look at the cluster. You'll notice there's no cluster here as well. So I'm going to jump back here, click on the run that's executing. So right now, this pipeline is executing. And the way that JFrog Pipelines works is it uses what's called node pools. And so we have these build nodes that execute the tasks that we specify in our pipeline. And I'll show you that. So we have a node pool right here. This particular node pool is set up, is running on AWS. And it's set up to spin up EC2 instances automatically. It tells you the size and the type here. And you can see what's happening right now. There are some nodes. Someone else is using a node. They kicked off another pipeline. I'm betting that this is our node. Yep. So this is our node that's going to do the operations. So this is a dynamic node pool. So these nodes will be spun up. They'll be used for execution. And then when they're not used anymore, they'll go away. The pipeline node pool also supports Kubernetes. And so in that situation here, you'll have a bunch of Kubernetes nodes, and then it'll spin up pods to do the execution. Now, to execute our pipeline, we need to have a couple integrations. One is integration to GitHub. So that allows us to pull the code down or be notified by GitHub. And also the integration with AWS. I'll show you what that looks like. If I jump over to integrations, I have a name for these. Let's see here. Oops, put the wrong button. There we go. So for the AWS integration, it's pretty simple to set up. It's just creating your access key ID and your access key. You specify those here, and then you just call this in your pipeline. Similarly, this is my GitHub integration. Same thing, you're going to generate an access token in GitHub. You place it here, you save it, and then you can access this from your pipeline as well. And that'll give you access to AWS and GitHub. If I jump back to the pipeline itself, I'll call out here, oops, I'm being used. So they're being called out in these various steps here for integrations, like here, not that one. Let's go down, here we go. So here is the AWS integration. And then on the repo itself, we have the GitHub integration. That's actually specified in a values.yaml. So what we've done is we've templatized the pipeline. And so if you're familiar with Helm chart, it uses the same kind of format. So you specify all the values here. And then the pipelines will pick up those values. So it makes it really easy to, if you need to reuse this pipeline again, you can just make some value changes and it'll pick it up. All right, so let's see where our pipeline is at right now. Okay, so it looks like we're processing the first step here of building. Let's take a look at what's going on here. So when you're looking at JFrog pipelines, what we do is we provide real-time logging. And so each step here is represented. These steps here are the same names that are in our pipeline YAML file. So we have this Docker build. This is currently executing right now. So it's executing the Docker build task. And this will take just a few minutes.
And
so it looks like
meanwhile, this is getting executed, Jeff, as in this step is also doing the Docker build, right? Can you talk a little bit about the partnership of how that will benefit customers, about bypassing the rate limiting and whatnot?
Yeah, absolutely. Yeah. So If folks are not aware, on Docker Hub, there are some rate limiting when you try to pull your images. I believe it's something around 200 pulls per day for anonymous accounts. But if you're using Artifactory, you have unlimited access. You'll be able to pull as many images as you need through Docker Hub going through Artifactory. And like mentioned earlier, the caching as well offers some optimization. So if you have multiple development teams using the same packages, it's only going to be pulled once from Docker Hub. It'll be cached on that Artifactory instances and be able to serve those multiple teams. Great question. Looks like there's another question here I see in the chat. What are the differences between Jenkins versus JFrog? In some respects, they're similar. They're both CI/CD engines. They both work off of a concept of having these build nodes execute these tasks. But obviously, you can see here that JFrog Pipelines uses a YAML format that I think it's much easier to understand. Jenkins has its own syntax and format for that. You can also run JFrog Pipelines in the cloud as a SaaS service. So that's one other big difference. All right, so let's see. So if we move on to the next step, we've done the Docker push. So what this has done is it's pushed the built image to our dev repository. The next step here, published our build information. So in this situation here, in this pipeline, it's collected some environment variables. And so it's storing that with the build. It moved on and promoted. Here, it promoted that image to a production repository. And so now the last step here is the deployment and calling Docker Compose. So we can monitor this real time. So what's happening right now is we've installed the Docker CLI. Looks like you can see right here, we've created that ECS context. We're using it. And now we're going through and creating all the infrastructure based on that CloudFormation template that's generated from this. Now to complete that magic trick, we'll go back to look at CloudFormation. So there you go. So now you see this was the CloudFormation template that was created from Docker Compose. You can see it's executing right now, creates in progress. So again, it's going through and creating that ECS cluster. You can see looking through this, it's creating the load balancer, the ingresses. If I go over to ECS, you can see our cluster has been created. So now probably what it's doing is it's working on creating the task definition and the service. So that should be up in just a second. All right, so you see it already has a task definition there. So I'm imagining just a few more moments. Let's see where we're at. One thing I'll point out is, so this is the first time that was created. I think it's going to take about 8 or 9 minutes. Big chunk of that time is creating that ECS cluster. But in a real CI/CD scenario, you're going to make changes to your code. That's going to automatically kick off this pipeline again. But the next time around, it will use the same ECS cluster. And what it'll do is it'll update those CloudFormation templates. And so in that situation, it'll run much faster.
Real quick, while we're waiting, so we had a couple questions around, is this recorded and we'll get access to that? Yes, absolutely, it's recorded, and we'll send that out in an email tomorrow. So definitely keep an eye on your inbox if you're gonna come back and watch the recording again. And also Jeff dropped in the GitHub repo, so you can use that, take a look at that code. But yeah, just wanted to let everybody know we've gotten that asked a couple times.
Thanks, Peter. So right now we're just waiting a few minutes here for this to complete.
We can take, do you want to tackle a question real quick?
Yeah, absolutely.
Okay, awesome. So Tom asks, how do you integrate this type of solution with policy as code when CloudFormation is dynamically generated by Docker Compose? Well, maybe we can all tackle that, but maybe Jeff, you want to kick that off if you want? It's an interesting one. Yeah, maybe
Policy as code. Maybe Anuj, since it's cloud formation. I'm
Yeah.
gonna pass the buck.
You know, clarify that question once again, Peter. Sorry.
Yeah. So how do you integrate this type of solution with policy as code when CloudFormation is dynamically generated by Docker Compose? So I think the question is asking, we have policies around our CloudFormation, scanning our configurations and those type of things. How do you enforce those when this is dynamically created?
Absolutely. Great question. It's a two-step answer. First step, the Docker Compose up command is, imagine that as a wrapper, which kind of generates the CloudFormation templates as well as deploys it, right? You can stop it at the very first level, which is Docker Compose convert command, which will simply generate the CloudFormation template, right? And you can run the policy engines on top of the generated CloudFormation template using which were generated using Docker Compose convert command, right? Yeah, I think, and yeah, that is step one. Step two. Now, let's say if you have to integrate with any policy engines or anything to be very specific, right? Or if you have to create your custom architecture, which is outside of this opinionated infrastructure that is generated, you can do two things. First thing is you can modify the templates which are created using Docker Compose convert command. And second thing, there are overrides, as I mentioned earlier. You can use Docker Compose overlays essentially to modify only the specific sections that you want to override, and not necessarily modify the entire generated opinionated infrastructure. But you can use AWS CloudFormation plugin and use that in your Compose overlay files to override a specific section which conforms to your policies which are enforced on the organization. I hope this took a little long, but it's a great question. It is a two-step process in my opinion.
Yeah, thanks, Anuj.
Yeah, thanks, Anuj. So while Anuj was answering that question, our ECS deployment step here completed. So we've created that cluster and now we've deployed the app. You can see the messages here. The app is ready. So what I'm going to do is just go ahead and go to the URL for the app. It'll take a second here to load. There we go. And so this is our app that we've just built. Again, we built the image. We pushed that image to Artifactory. We use Docker Compose to create the ECS cluster that this is running off of, and also take that image and deploy the application into that ECS cluster. So I believe that's finished up our demo. Just sort of some closing items here. So all the demo code, I put the GitHub repo in the chat, so you can take a look at that. We have an upcoming workshop that uses some of this code. So you'll be able to get a hands-on in your own AWS environment with your own JFrog instance as part of this workshop. So keep a lookout for that. You'll get an email on that. Also, later this week, we have an upcoming AWS DevOps workshop series. Again, we'll be looking at CI/CD with JFrog Pipelines, but in this situation, or as part of this workshop, we'll be looking at EKS instead. And then you can use JFrog for free. Again, in AWS Cloud. We also have it on AWS Marketplace. So that's what it looks like on AWS Marketplace. I'll go ahead and include a link in the chat. And then Peter, looks like Anuj, any last minute closing comments?
Yes, first and foremost, we all are customer obsessed companies. We love to hear a feedback from you. Docker Compose integration is available as an open source product. Please give us feedback on the things that you feel are which will make it useful for your specific context, so that we can put it in the roadmap and iterate further on that. we have all our eyes and ears on the GitHub page. And Peter, if you want to talk more on that.
Yeah. So two things real quick. I would be remiss if I didn't invite all of you to DockerCon, which is not this coming Thursday, but the following Thursday on the 27th. It's free, all virtual. We have over 45 sessions. We're going to be having announcing some cool stuff and really great breakout sessions. Anuj will be there speaking. Nice deep dive along these lines also. And then Anuj and team have put together a hands-on workshop that I think we mentioned it earlier. You come out to be able to register, but there you'll be able to get hands-on to the GitHub repo into JFrog, and we'll walk you through working through this exact demo. Not the exact demo, excuse me, another demo, but very, very similar. And you'll get the hands-on to try everything out, ask us questions. So look for that in your inbox, sign up for that. We'll be running that a couple of times. I think that's it. All that I have. But again, thank you so much for coming. Jeff, Anuj, thank you guys for walking us through this. It's been wonderful. And there we go.
Thank you, everyone. Oh, sorry. Go ahead, Peter.
Forgive me. I just saw Anuj put in the workshop there. So that has the code in it. If you go to docker.awsworkshop.io.
Okay. And as we mentioned, you will receive the recording of this webinar so you can review everything again at your own pace. That is it from us for today. We wish you all a great day, and we hope to hear from you soon. Goodbye.
Thanks, everybody.
All right.
Thanks.
Thank you, everyone.